And the textbook does not do this. They give you problems and they say, guess. So we're going to try to make that a little easier for you. Now we want to find antiderivatives. Okay, so what is the question asking? If I want to find the antiderivative of x cubed, then I'm really asking you the derivative of what gives you x cubed. So you're going to reverse the process. This is day 2. You don't have this on day 2. You have the next slide. The next slide looks like this. Yeah, that's what it should look like, right? Yeah, you should probably try these. Once you see them, it won't be bad. Well, the derivative of what is x cubed? The derivative of what is x cubed? Well, what's the derivative of x cubed? That's 3x squared. Not big enough. So what would you try now? The book wants you to just guess and check. We're going to do these, and you'll see the pattern, and then you'll know the rule. X to the what? 4. Well, if I take the derivative of x to the 4th, I get what? 4x cubed. I got the x cubed, I don't want the 4. Divided by 4. You'll see a pattern here. It'll be just like our derivatives. This is the short way. We could add the rectangles. An antiderivative is the area under the curve. I'm not going to prove it to you, but there is a request that maybe I put together with proof of that. It's tricky. Okay? And by the way, couldn't there be a number added on there? What's the derivative of a constant? 0. So couldn't you have a constant added in here? We'll call it C. Now, how do I know that's the antiderivative? I'm just going to take the derivative. Okay, Sarah? So what's the antiderivative of x squared? Take a guess. X to the 3rd. Check. The derivative of x to the 3rd is 3x squared. I don't want 3x squared. I just want 1x squared. And divide by 3. Because what's the derivative of a constant? Couldn't there have been a number there added on? You always have to have plus c. And it's critical. I'm not going to be real picky initially, but as we go on and you get more used to adding the c, and then I'll start getting pickier. There are problems on the exam where if you don't add the c on the free response, you'll only be able to get like 1 out of 6 points. Right, so you have to add the c in. And you get a point for just adding c. That's not too tough to do. And then you get another point for trying to figure out what c is. Even if it's wrong, just for trying. They try to give you points. Okay, how about the antiderivative of x? X squared over 2 plus c. Well, the derivative of what would give you? Just x. It's just the slope. Right? Slope of y equals x is 1 plus c. So we're just reversing derivatives. We'll do those in a second. Have you guessed the rule yet? What are you doing with this was squared, this became cubed. This was to the 3rd, this went to the 4th. So the antiderivative of x to the n, x to the n plus 1 over n plus 1 plus c. And you know what else we need? We need to figure out how to write an antiderivative. I need a symbol. I don't want to have it in words. Find the antiderivative. So there's a symbol, and it's called the integral symbol. You've seen it. You know this one. From a to b of f of x dx. We know that's a Riemann sum. That's the area of all the rectangles added up. From a to b. That's called a definite integral. I think it's in the reading there on the next page. But let me write it anyway. That's a definite integral. I do it this way. I have a definite answer. I'm going to get a number. Okay? This is an indefinite integral. There's no a and b on it. And it looks the same, except it doesn't have the a to b. Okay. This is what you have to know. This means, this symbol, the dx, well, first off, it's the base of your rectangle, and f of x is the height of your rectangle. But in calculus language, it means find the antiderivative of the function between those. You guys are going to have questions for me. If you don't pay attention right now. This is the antiderivative. The two things together. Antiderivative of f of x. So to put this into the symbols that I just invented, I didn't invent them, but that somebody else invented, there's the integral symbol, that's not enough, and then you have to have the differential dx. You need both together. Some of you are going to look at that and say, where did the dx go? It's a symbol. These two together mean find the antiderivative. And it's just what somebody made up. And it is connected to the geometry, which is why the dx has to be there. An example of that, of something that we do like that all the time, is what is a square root symbol? What does that mean? Like if I do the square root of 9. We know what the answer is. 3. I'm going to stop this here. You guys here. Square root of 9 is 3, right? What is a square root? Find the number that you multiply by itself to get 9. I don't want to write that. So somebody made the symbol. You don't question the symbol. You've seen it for so many years that you don't even think about it. Well, you could ask me the very first time you see this is, where did that little square root symbol go? It's an operation. It's the same as saying to me, when I add 2 and 3 and I get 5, you don't say, well, where did the plus sign go? The plus sign tells you, I want to add those together. They could have made up a star. They could have made up any symbol. We just have grown up with the plus signs, so we don't even question why it is what it is. And same with the square roots. So this is just a new symbol that means this with this means find the antiderivative of what's inside. And it's on the next page, and I'll hit on it again and again and again until we get it. Find the antiderivative. Now, that's all it means. It's like a square root. It's like a squaring symbol. That's what that means. That means multiply 3 times 3. They could have done this. They could have made it, written it like that. They could have done anything they wanted to say. What do you mean by 3 times 3? They made it 3 squared like that. Unfortunately, my computer doesn't do that unless I have a special program. To write this on my computer, I have to do this. And I don't like doing that. I have to read a lot of that stuff, and I don't like reading. I actually translate it back to what I'm familiar with. So it's just a symbol. Okay. Now, this is called the power rule. If I write slow, it won't do this. My smart board's having issues today. Okay, that's the power rule. That's an integral. An integral is an antiderivative. An integral is an antiderivative. That's the integral symbol. See, this is an indefinite integral. So when you did those geometry problems, finding those areas under the curves, if we knew the function, we could have found an antiderivative and done it algebraically, or we could do it with geometry. The problem is you can't always find an antiderivative for everything. The greatest integer function. I can find the area under the greatest integer curve, but I can't find a formula to integrate. I mean, I can't figure out what the antiderivative is algebraically. So I always do my problems with geometry first, if I can. The minute you see a circle or a triangle or a trapezoid, any, of your normal geometric figures, you know it's going to be a geometry problem. You can go and look at AP questions and just look at the figures and you go, oh, I'm going to be finding the area under this curve. You're either going to find an antiderivative or a derivative. So first semester was easy. You just had to find the derivative. Now you got to make a decision. Which is it? So this is the power rule. X to the n is a power. Well, the problem with 1 over x and 1 over x squared, all these guys, these are not powers. They are rational functions, not the way they're written. And I don't have a rule for rational functions, but I do have a power rule. And so if I want to write this as a power, I would write this as x to the negative 1. So let's go ahead and try our rule and see if it works with the negative exponents. So then this would be x, you're going to add 1. Is it easy to go the wrong direction? Yes, even I almost did it today. So it's negative 1 plus 1, because you're just going to do it in your head. Divided by, and that's okay, negative 1 plus 1. Uh-oh. What happened there? I'm dividing by 0. Can I do that? No. Power rule does not apply to that one. Would you like to know what that one is? You're going to have to know what it is anyway. So the antiderivative of 1 over x dx, remember that's just the symbol saying find that, is the log function. Isn't that interesting? The only one that doesn't, of this group, that doesn't fit the power rule. And we haven't done composite functions either. That's chapter 6. These will be just plain old power rules or something else we might recognize. So what's 1 over x squared? That's x to the y. I want to write it as a power now. Negative 2. Okay. Now let's try it. Does the power rule work for this one? It's x. Negative 2 plus 1 is negative 1, and then you divide by that. And that's fine. Do I care about simplifying? Only if I'm on the multiple choice section of the exam. Otherwise, I don't really care. It's getting messy. Okay, what's this one? This is x to the negative 3. What's the antiderivative of that one? It's x to the, let's go up 1. Negative 3 plus 1 is negative 2 divided by negative 2. And I don't care if you simplify. Not important. And if you simplify wrong, I'll mark it wrong. What's this one? This is x to the negative 4. These are all powers. Here's the deal with antiderivatives. There's only so many you can do, and you have to make the function look like the ones you know how to do. That looks like a power if I rewrite it. And then I can do it. And so when we get to the composite functions, we're going to have to figure out how to reverse the chain rule. Sometimes you can just see it, and sometimes you can't. So this is what? X to the y. Go up 1. Negative 4 plus 1 is negative 3 over, negative 3 plus c. This slide is only here for you to just kind of observe what happens. Guess and check and say, oh, okay, to do derivatives, we subtract 1. To do antiderivatives, we go the other way. We add 1. Make sense? Is that okay? Okay. The formal math stuff. We call capital F an antiderivative. How do I really know I found the antiderivative carefully? Let me give you another example that you know. If I factor x squared minus 4, and it's x minus 2, x plus 2, what should I really do before I go on to the next problem? I should really check it and multiply it back out and see if it works, because factoring is kind of a guessing and checking thing. So how do I really know I have an antiderivative? Take the derivative, and that's going to be down there. So if f is my antiderivative, then f prime of x would have to be equal to my original function, little f of x. So let's try example 1. Okay, find an antiderivative for this. So we'll call it capital F of x. That's pretty standard practice. Now, sometimes I'm clever, and sometimes I'm not clever. It depends on how tired I am. So we're going to pretend we're not clever, Because some of you are already seeing what it's going to be. Anybody know what it's going to be? Derivative of what gives you 4x cubed? X to the 4th. How do you know? Take the derivative. That's you know if you did it right. But we're tired today, so we're going to ignore the 4 because we can. Just like we did with derivatives. Seems like since they're opposite operations, they should be connected in some way. And then this is x to the 4th divided by 4. What happens to the 4s? They cancel. It's okay if you can go right to x to the 4th, but you won't always be able to do that. Plus c. And then I talk about right here that the integral and the dx together mean find the antiderivative. And they wanted it to be the same as the definite integral, so you could see that antiderivative is the area under the curve. Now that should bother you. Why is an antiderivative the area under a curve? And that's what I would have to prove tomorrow, which I will present without proof. But if you're interested, I'll make a little video with the proof and you'll see how it's connected. It's really cool, but I do have to do some Newton thing to do it. And some sigma stuff. Okay, so there's my power rule just written out again. And then somebody asked me this question. What is the antiderivative of f prime of x dx? Because I've seen this question. It's what? It's easy. It's just f of x plus that arbitrary constant. So then, what's the, I actually might even be doing a homework problem, I don't know, because I've seen this. What's the antiderivative of the second derivative? The first derivative. Okay, so you see it's just the same as a derivative, but an inverse of it. It's reverse f prime of x. Whoops, plus c. Got myself next. So there it is. How do you know that really is the antiderivative? We could take the derivative of this function. Oh, I kind of like this. I'm going to take the derivative of both sides. We'll see what this means next week. But it means what it looks like it means. What's the derivative of an antiderivative? What's e to the ln of x? These are inverse operations. What do you get? X. These are inverse operations. This just obliterates that integral and the dx. Remember, the integral and dx are kind of together. So this is d dx of this side, and what's the derivative of that? Well, it's r plus 1 times x to the r plus 1 minus 1, and this is just a constant. I know it's bothersome because it's a letter, but it's just a number. And plus the derivative of my constant with respect to x. Well, what happens to the r plus 1s? They cancel, and guess what? I get x to the r, which is what I wanted. And then this is 0. It was the change in c, which is 0. So how do you prove a function is an antiderivative? Just take the derivative. So it's like factoring. Really, to know if you factored correctly, this is an easy one, but some of the hard ones, you really have to multiply it back out and double check yourself. And even I do it, and I've done every one that's reasonable. I've done every one hundreds of times. I canceled the r plus 1s. I added these, r plus 1 minus 1. So that's just x to the r, and r plus 1 divided by r plus 1. Do I need to do the quotient rule? Remember, this is just like 5. It's just a number. So you can ignore it. Remember how you can take the derivative with respect to x of 5 times f of x? And remember how you can just pull out the 5? This is 5 times the derivative with respect to x of f of x. R plus 1 is just a number. I know it bothers you. You're saying, well, it's got a letter in there. No, no, no. R is just a number. How do you do a derivative? You take the exponent, and you write that down. And by the way, I have this just hanging around. I'll put it over there just to get it out of my way. And then what do you do with this exponent? You decrease it by 1. Remember that the derivative with respect to x of x to the n is n times x to the n minus 1. So if I do a reverse process of x to the n, it would be nice if it was just that. And a lot of you will write on your exams just that, and you will get credit, by the way. But it's not right. You really need this little differential there because it tells you what your variable is. Because actually we could have functions of x and y, which is what the multivariable calculus class is. And how do you do antiderivatives when you have two variables? Yes, it's not that bad. Actually, it's not bad at all. And what's this? Well, to do a derivative, we brought the exponent. We did multiplying by the exponent, so let's do the opposite. Let's find the exponent. This was subtracting 1, so what's the opposite? Adding 1. You multiply by n, what's the opposite? Divide by n plus 1. I'm showing you they are inverse operations, so you can think of it. I'm going to do the opposite of whatever that was there. So let's just do some problems. Oh, wait, we'll do this first. The antiderivative of 1, remember, we're only looking at this. That, when I look at that, it says to me antiderivative of 1. That's all it is. All right, once I'm back to my right hand, the right path. And you got to be careful with the trig ones. Because I want to say the antiderivative of the sine function is cosine, but what's the derivative of the cosine? Remember, we always check it. The derivative of the cosine, I got a problem. If I say it's just cosine, what is that? Negative sine. So to find the antiderivative of sine, I have to have a negative here. It's not going to work. How do I know? Take the derivative of this. If you don't have that negative, you're going to get a negative sign, and I don't want negative sign. But the antiderivative of cosine is sine. Because what's the derivative of sine of x? It's cosine of x. So those are the big ones you know. And actually, I really could have added another one in here. What is the antiderivative of e to the x? It's what? It's e to the x. So there's only so many you know. So how are we going to deal with composite functions? We'll deal with that in chapter 6. Plus c. Thank you for reminding me. Now, when you, on your quizzes and stuff, when you forget to put the plus c in, I only take a point off once. If you have 6 of these to do and you forget the c every time, I just take it off once. I don't take it off all 6 times. Actually, maybe I'll point it a little bit. Okay, properties of integrals. You can pull any constants outside the integral, so you can ignore the constants, and you can distribute the integral. So I could write that as an integral and distribute the integral over each one of those. I'm just going to find the antiderivative, because that's really all it's asking. So what's the antiderivative of that thing? Take each one by itself, each term by itself. So the derivative of what? Now, if I'm tired, I might not see the answer. I might just ignore the 3. And then all you do is raise x squared up 1. So it's x to the what? Third, but it's divided by 3. As long as we're not on multiple choice, I don't care if you simplify. But if you simplify wrong, you know what I'm going to do. I'm going to mark it wrong. Plus. Are we tired today? Oh, okay, so let's just leave the 10 there and not try to think too hard. So then this is x to the first, so it's going to become x to the second over 2. I might have been able to look at it and see it was 5x squared, and maybe not. I don't know. What's the next one? Plus. We'll get to see in there in a second. What's the antiderivative? Not derivative of 7. What's the antiderivative of 7? What did you take the derivative of to get 7? It would be 7x. We're going the other direction. Do you see how they're inverses of each other? Plus. That's really important to recognize when we get to the second fundamental theorem, which is always on the exam. Emphasized heavily on the exam. And that's it. Now, how would I know I did it right? Just take the derivative and see if I did it right. The 3's would cancel here. I get 3x squared. The 2's will cancel. I get 10x. The derivative of 7x is 7. And the derivative of my constant is nothing. No, I don't care. If you simplify wrong, I'll mark it wrong. Just because that's what they do in the exam. So you're better off on the exam If it's free response, to leave it not simplified. If it's multiple choice, you probably have to, so you can match it up. Okay, what about this one? This is not a power. These are rational functions. Rational functions meaning fractions. Can I write it as a power? Yeah, then I can use the power rule. X to the negative 3 plus 6x to the negative 7. Wonder what they're doing with that. Okay, so what's my antiderivative? Yeah, you should hopefully be ahead of me. I'm right, my left hand will make me slow. So it's x. Now we have to go up 1. It's easy to go down 1 because it's negative. But it's up 1, so it's negative, not negative 4, negative 2. So easy to make that mistake. In my thing, I would suspect that if it's on the multiple choice part of the exam, that will be one of their distractors to make that mistake. Plus, I'm going to ignore the 6. I don't know what's going to happen with the constant, even though, I did this problem already. And then this is going to go up 1. I wanted to make it negative 8, I'll be honest, over negative 6. So you can see that'll work out nicely for me. Plus C. I'm not even going to simplify them because that's not my purpose today. I know you know how to do that. And if you do it wrong, it's just a silly mistake. Okay, ready to try some more? There's actually 2 ways to do this. Again, it's a rational function. I don't know what to do with that. I can't use the power rule because it's not a power. What do you want to do with it? Yeah, you can do each one individually because it's really distributive property. The other class multiplied by x to the negative 5th. They put it up at the top and distributed. I don't know. I think it's easier to do this, but it's up to you. So if I divide this out, it's 4x to the 6th. I'm actually going to write that over x to the 5th. Plus 3x to the 5th over x to the 5th. Minus 8 over x to the 5th. Okay, I do have to simplify this before I can take the antiderivatives. I don't know how to do that at all. So what does that give me? This gives me 4x, right? Question, ask me. What's got x to the 5th for the next one? I'm just dividing. I can divide this into each one of these little guys. So if I have a plus b plus c over x, I don't want to do it with a d because I get my d's and b's mixed up. Anyway, it's the same as a over x plus b over x. If you say this, cross that out and say this is x to the negative 5, you get the same exact answer. And it's whatever's easier for you. In the last class we did it that way. I prefer this way, but that's my preference. You may prefer it the other. To do the method with x to the negative 5, I have to know how to multiply exponents. I have to multiply numbers with the same base. What do I do with the exponents? This is easier in some senses. That's 3, right? And this is minus. Now I got to get that x to the 5th in the numerator. X to the negative 5. I can go right from the original problem right to that line, that last line right there, without writing anything out in between. So it's up to you. And let's find the antiderivative then. And we're not going to simplify because I don't really care. Although some of you will know right away what that one is. As you do more, you'll recognize them. But this is 4, and then it's x to the what? Second over 2. Some of you maybe looked at it and said, oh yeah, it's 2x squared. Because some of you will just see it right away. Plus, it doesn't really matter. 3x minus 8. I'm going to ignore that. And this is where I'm really not sure what's going to happen with that number in front. And this is x to the what? Negative 4. I'll be honest, I wanted to make it negative 6. If it makes you feel any better. And just leave it. I don't care. That's a different problem if you can't simplify it. Ask, what? You want me to simplify? It's 2x squared plus 3x. And the two negatives cancel each other out, so it's plus 2x to the negative 4. Ooh, now what am I going to do with that one? See, that's a composite function. That's a power within a power, and I haven't shown you what to do with those. So there's only one way you can do this. What can you do with it? It's begging me to do this. If you were in a regular algebra class and you were just given the y squared plus 4y, all of that to the second power, they would tell you to do what? Yeah, square it, multiply it out. So what are you going to get for the first term? Y to the 4th. Now, do you know what the middle term is going to be? The easy way to do this when you're squaring, if you want to memorize something, it's just a process. You could actually show the two binomials times each other and see what happens. But you take 2 times 4y times y squared, and that will give you the middle term. It only works for squaring. It doesn't work for cubing or anything else. So this is plus, and 2 times 4 is 8. And I have y times y squared, which is y to the 3rd. Plus, and if you have a CAS calculator, it doesn't matter. Plus 16y squared. A CAS calculator. Mine doesn't work on my computer anymore because I ran out of time on it. But it's just, I wouldn't even do this. I would type it in like it's written and it will give me the answer. So what do engineers do? They use Mathematica or they use some sort of software. They don't ever do derivatives and integrals. No, but you got to understand what goes on behind. They know what happens behind the problems. And actually, I think a lot of things are probably done numerically. But I did visit one of my friends who's an engineer out in California, and I was touring his office, and I was looking at all the engineers' offices, and many of them had their calculus books sitting up on their shelves because they did have to refer to it once in a while. Kind of interesting. Okay, so now we're going to find the antiderivative, and so that's the easy part, probably. It's y to the what? 5 over 5 plus 8. I'm tired today, so I'm not going to think. Y to the 4th over 4 plus 16 y to the 3rd over 3 plus c. One more. It's a power, but it's a fractional exponent. So I'm going to ignore the 3 and put it out in front, and it's this. And it's just some fraction work that we have to work with. The power rule works for fractional exponents, not a problem. So it's 3, and now you have to do is you have to add 1 to 2/3. Oh, can I go right to 5/3? That would be nice. It's 5/3, and then what do you have to do? Divide by 5/3. No, the 3's don't cancel. Why does dividing by fractions work? Remember, if you were to take 3 divided by, because that's what this is, 5/3, then that would become what? 3 times 3/5. So they don't cancel, do they? But why do you multiply by the reciprocal? Because your teacher told you so. Well, let's understand it, because if you understand, you remember. How can I get rid of 5/3 here? Multiply by what? 3/5. And if I multiply the denominator by 3/5, we have to be fair, I have to multiply the numerator by 3/5. And so when you divide by fractions, you multiply by the reciprocal. It's because of this. And I don't see why they don't show that to you in elementary school. When you learn that, they just say, this is how you do it. Because it's not hard. And this gives me 1. That's why you multiply by reciprocals. They're called multiplicative inverses, because they undo it. Okay, so when you are going to raise this exponent up to the 5/3 and divide by 5/3, you're going to skip this step that I just did in the black here. You're going to go right to the 3/5. You're going to say it's 3 x to the 5/3, and dividing by 5/3 is the same as multiplying by 3/5. You can, don't forget plus c. But if it's multiple choice, you're going to have to know how to simplify. So that would be 9/5. And you could check by taking the derivative, and that's x to the 5/3 plus c. And that's all there is. So all I did was introduce an integral symbol. First, I challenged you to see if you could figure out the derivative of what gives you this, which is the way the author wants you to do the whole assignment, which is kind of crazy. Or we can figure out what the power rule is, but don't forget the other ones. You know sine and cosine, and actually you know more than that. We'll do those tomorrow. That's what we're going to do. So the antiderivative of the power of x to the n. And remember that the symbol that really is the base of my rectangle, and that is a sigma. But it has a double meaning. It means find the antiderivative. Why the antiderivative is equal to the area should bother you. You won't, you'll just believe me. And how do you do it? You raise it to this power. It's not proof, it's done by observation. Were there any questions? Well, we got to, what's due? We got to make that clear. Okay, I don't know if there are any questions on the homework. I could get 5-2 from you today. I should get any corrections to formative from the last 2 things that we've done. You need that, it's pink, that calculus assessment thing, that calculus paper. And if you can recognize a derivative, you can use the derivative rules. You don't have to actually do the limit. Okay, and then I'm going to get from you section 5-2. If you want to turn it in today, that's fine, but you won't have it to study from. And the quiz has 4 multiple choice AP questions. That's it. It's worth 12 points. I give you 3 points. I give you points for your work. Section 5-2 should be done by now. Like I said, you can turn it in now if you want, or you can turn it in tomorrow. And then section 5-5, that really should be done, because if you don't know that, you're in trouble. You have to know the trapezoidal rule. It shouldn't take you too long to do the quiz, actually. So this is what I'm going to collect tomorrow. I'm going to have a fun weekend, huh? True, but you guys want your points because you did it, right? So you do want that. You want your points. You pretty much earn all A's. Yeah, my medians were between A's and A minuses, depending on which class it was. Okay, what you do then for homework, you should continue working on 5-3 if you haven't done much. Some people, it's not that long. So check the assignment sheet. I do have another worksheet for antiderivatives, but I think I'll give that to you tomorrow. And then there is the that white packet. You now know how to do average value. Remember how to do average value? The AP packet. You can't do the AP quiz because we haven't done everything yet. That was yesterday. But do you want me to write it up here again? How do you do average value? Okay. Because it's new. I mean, it's not new to me. No. The average value of my y values is equal to the antiderivative from a to b. It's an antiderivative. Now we could actually do it algebraically if we know how, of f of x, or I'd rather do it geometrically if I can though. Dx divided by b minus a. So you just find the area under the curve, and that's accumulating all the area there. And I want to know what the average is, so I don't want a big number. I just divide by how wide the interval is, and that'll bring me back down to where my y values were. It's the same as dividing by n. I suppose you were just given that too. Okay, any questions? Then you have some time to work. And tomorrow, I'll give you the fundamental thermocalculus tomorrow, and it's fundamental. You got to know it, and that won't take long at all. Only if you're willing to not have it to study.